Hello everybody, welcome into another lesson. So I know I said this next lesson was going to be inverse trig functions, and that's the way the book would have me do it, but inverse trig functions aren't going to make much sense to you if we don't first show you the graph of regular trig functions. So for the next several lessons, we're actually going to be graphing trig functions to help you understand. So here we have the standard graph of y equals the sine of x. As you see, it oscillates, it keeps going. In fact, it would do this to infinity. It never stops anywhere. It oscillates between a y value of -1 and a y value of 1. In fact, that is the range of this particular function, of the standard y equals sine of x. Your domain, of course, is all real numbers. Now, it's important to note then, in general, for the sine function, you'll have y equals the form of a sine of bx. That a is your amplitude. So when you have y equals sine of x, your a is 1, which means it's going to multiply the numbers of your range. So if I had a 2 on here for 2 sine of x, my maximum value of the range would go all the way to 2. My minimum value would go all the way down to -2. It stretches it vertically, if you will. That's what the amplitude does. And if you look here, look from 0 to 2 pi. I have these charted out from 0 to 2 pi and then all the way down to -2 pi to the left. It completes one period in 2 pi. It goes from 0 to 1, back to 0, down to -1, back to 0 at 2 pi. That's what's called a period. So in general, that bx inside the sine, to find the period, you'll take 2 pi, divide it by the absolute value of that b. Well, in this case, your b is 1, so your period is 2 pi. So it'll complete a cycle of the graph in 2 pi. And this is what's called oscillating. It oscillates. It just goes back and forth. So this is the standard graph of a sine function. How do we graph it? Well, we're at 0. What's the sine of 0? It's 0. So you'll have 0. The sine of pi over 2, that's 1. So you're up to 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. So you get a nice little curve going to the right, and then sine of -pi over 2 is -1, sine of -pi is 0, sine of -3 pi over 2 is +1, and the sine of -2 pi is 0. So you get a nice curve going to the left. It just oscillates. And we're also going to do the graph of the cosine function today. So cosine and sine we'll do today. The next lesson we will deal with reflections and translations of the sine and cosine functions. Eventually we'll graph all the other ones, but for this lesson we're just going to graph the sine and cosine the standard way. Alright, let me just erase this here because we're going to set up the cosine function now. We'll graph all that. Let me just write down these numbers here. It's kind of important. Alright, now let's say we have y equals the cosine of x. So we're going to be given y equals the cosine of x. So you could have a function of the form y equals cosine of b of x. It's the same deal. The period is, the amplitude is your a, your period is 2 pi over b. So in this case, if we're looking at y equals the cosine of x, my amplitude is 1, which means my max value of the range would be 1, my minimum value of the range would be -1, and the domain is still all real numbers. The period is 2 pi over b, in this case 2 pi over the absolute value of 1, which is 2 pi. Now the graph looks a little similar to the sine, but it's different. Because if we put in 0 for x, the cosine of 0 is 1, so we're actually up here. Now the cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is back to 1. So let's go ahead and draw a nice curve through all these points. All right, let's see. The cosine of -pi over 2 is 0. Cosine of -pi is -1. Cosine of -3 pi over 2 is 0, and the cosine of -2 pi is +1. So now let's draw the curve going to the left. And there is the standard graph of your cosine function. So again, your minimum value for y is -1, your maximum value for y is +1, illustrating your range, okay? And your domain is all real numbers. It looks similar to the sine, but it's different because at 0 you're at 1. But look at this still, it completes a period in 2 pi. So these are the standard graphs of the sine and cosine function. And again, it oscillates. It'll keep going like this to infinity. Now, let's get into let's get into different amplitudes and different periods, okay? So, here's what we're going to do. Let's see here. We have y equals the sine of 1/4 x. So y equals the sine of 1/4 x, okay? Well, let's look for our amplitude first. What's the coefficient on the sine? It's still 1, right? So my amplitude's still going to be 1. That hasn't changed. But now let's figure out the period. So for the period, it's going to be 2 pi over the absolute value of 1/4. Well, the absolute value of 1/4 is 1/4. 2 pi divided by 1/4 is the same as 2 pi divided by 2 pi times 4. So you'll actually have a period of 8 pi. So the period is going to be 8 pi. So let's list 8 pi right here. There's 8 pi. Here's 4 pi. Here's going to be 2 pi. So that means 6 pi would have to go right here. You'll still have 0. It's important to label these on your going for your x-axis so you know where you're graphing. So here's -8 pi. I should say that when graphing, it's customary to include 2 full periods. That's what you want to do. Alright, so here's -4 pi. There's -6 pi. Here's -2 pi. Okay. So we have from negative 8 pi to 8 pi. It's, again, you want to include 2 full periods. So let's put in 0 for x, okay? Well, if you put in 0, you'll still get sine of 0. The sine of 0 is 0, right? Now, let's put in 2 pi. So what's 1/4 of 2 pi? That'd be pi over 2. Your sine would be 1. Now let's put in 4 pi. 1/4 of 4 pi is pi. Sine of pi is 0. Alright, let's put in 6 pi. 1/4 of 6 pi, that's 3 pi over 2, so that would be negative 1. Then 8 pi, 1/4 of 8 pi is 2 pi. Sine of 2 pi is 0. Let's start the curve going this way. Alright, so we got the curve to the right. Now let's put in negative 2 pi for x. You would get negative pi over 2, which would give you negative 1. Then put in negative 4 pi, you'll get negative pi. Sine of negative pi is 0. So you'll be back up to 0 here. Now put in negative 6 pi. 1/4 of negative 6 pi is negative 3 pi over 2. That would end up giving you positive 1. And then the negative 8 pi, well, that's going to end up being negative 2 pi, which would be 0. So now you can draw a nice continuous curve going this way. And there is your curve of the sine function that oscillates again with a period of 8 pi, with all your points clearly labeled on the y-axis. All right. Let's leave that up. Let's see what we got next. This time we're going to graph the cosine of 1/5 x. So we have a cosine. So the cosine of 1/5 x, well, the amplitude's still 1 because the coefficient on the cosine part is 1. Now for your period, it's going to be 2 pi over the absolute value of that 1/5 inside of the cosine. Well, the absolute value of 1/5 is 1/5. 2 pi divided by 1/5 is the same as 2 pi times 5. You'll have a period of 10 pi. So the period in this case is going to be 10 pi. That's going to be right here. There's your 10 pi. Here's 5 pi. This would be 5/2 pi. And then you'll have, let's see, 7.5 pi. That's going to be so 7.5 would be 15 pi over 2. And then we're going to do the same in reverse. You'll have negative 10 pi. And here's negative 5 pi. Negative 15 pi over 2. Then here's negative 5 pi over 2. Alright, so we got all our critical points. So what is the cosine? If we put in 0, you'll still get cosine of 0, which is going to give you 1. Now let's put in that 5 pi over 2. So what's 1/5 times 5 pi over 2? that would just turn into pi over 2, right? So it's going to be like we're finding the cosine of pi over 2 at 5 pi over 2. Well, that's going to then give you 0. The cosine at 5 pi over 2 here in this case would be 0. Now if we put in a fifth of 5 pi, that would be the same as the cosine of pi, which would end up being -1. Now, what about 15 pi over 2? Let's put in that. That'd be the same as the cosine of 3 pi over 2. What is the cosine of 3 pi over 2? That's 0. Then if we put in 10 pi, that's going to be the same as the cosine of 2 pi, which would end up being +1. So let's draw a nice little curve here. So there's the curve to the right. Now let's do -5 pi over 2. A fifth of -5 pi over 2, that'd be the same as the cosine of -pi over 2, which would also be 0. Then put in -5 pi, you would end up getting the cosine of -pi, which is -1. Now what about -15 pi over 2? A fifth of -15 pi over 2, that'd be the same as -3 pi over 2. What is the cosine at -3 pi over 2? That's going to be +1. And then put in -10 pi, that'd be the same as the cosine of... Wait, the cosine of -15 pi over 2 is 0. Excuse me. I was thinking of the sine for a second. Cosine of -15 pi over 2 in this case, because it's -3 pi over 2, would be 0. There we go. So then put in -10 pi, that'd be the cosine of -2 pi. Well, that would end up being 1. So now let's draw a nice little curve to the left. And here's your nice curve with a period of 10 pi for the cosine function. So you can get some really cool graphs, and a big application of these are going to be ocean waves, like how meteorologists and all those and scientists, they measure ocean waves using sine and cosine functions. That's actually really how they do it. All right, what do we got next? We aren't doing that one. How about y equals 1/2 sine of x? What if we had y equals half of a sine of x? So what's the coefficient on the sine? It's 1/2. That means your amplitude's going to be 1/2 in this case. So it's going to shrink this vertically. Now your period, alright, so inside the sine function you have a 1x, so your period is 2 pi over the absolute value of 1, which would just give you 2 pi. So the period still completes in 2 pi. So let's go ahead and label all our points here. There's 2 pi. Here's pi. Here's pi over 2. Here's 3 pi over 2. Here's -pi over 2. There's -pi. -3 pi over 2, and then -2 pi right here. So there's 2 full periods labeled. Now, what's the sine of 0? Half of the sine of 0, that's half of 0, still 0. Alright, now, what is the sine of pi over 2? That's 1, but what's half of 1? That'll only put you up here at a half. Now, what's the sine of pi? That's 0. Half of 0 is still 0. What's the sine of 3 pi over 2? That's negative 1. Half of negative 1 is, well, negative 1/2. And then the sine of 2 pi is 0. Half of 0 is 0. So let's go ahead and graph this function here. So you notice it's already shrunk vertically as far as the graph goes for the curve. Now let's do the same in the negative direction. So the sine of negative pi over 2 is negative 1. Half of negative 1 is, well, negative 1/2. What about the sine of negative pi? That's 0. Half of 0 is still 0. How about the sine of negative 3 pi over 2? That's positive 1 times a half is, well, a half. And then the sine of negative 2 pi is 0. Half of 0 is 0. So, as you see, this graph has really shrunk vertically. It's more horizontally stretched. Alright, let's do some others. Good one. Y equals 4 cosine of x. So y equals 4 cosine of x, okay? Well, what is our amplitude? It's 4, right? That's our coefficient on the cosine. So that means our range is going to go all the way from negative 4 to positive 4. Now, what's the period? Well, inside the cosine, you still have a 1x, so the period is 2 pi over the absolute value of 1, or just 2 pi. So let's go ahead and label all our points again here on the x-axis. Here's pi. Here's 3 pi over 2. There's pi over 2. Alright, 0, alright. Negative pi over 2. Negative pi. Negative 3 pi over 2. And then we have, last but not least, negative 2 pi. Alright, so there's my x-axis labeled. Now, what is the cosine of 0? That's 1 times that 4. You're going to be all the way up to 4. Alright, what's the cosine of pi over 2? That's 0 times 4, that's still 0. Now what's the cosine of pi? That's negative 1 times 4. That would actually put you at negative 4. And then what's the cosine of 3 pi over 2? That's 0 times 4 is still 0. And then the cosine of 2 pi is 1 times 4 is 4. So let's draw this bad boy. Look at that. That is a huge change already. It's really vertically stretched. Now what about negative pi over 2? Cosine of negative pi over 2 is 0 times 4 is still 0. Now what about negative pi? Cosine of negative pi is negative 1 times 4 as well, negative 4. The cosine of negative 3 pi over 2 is 0 times 4 is 0. Cosine of negative 2 pi is positive 1 times 4 is 4. So let's draw the curve now going this way. So look at how vertically stretched that is with that amplitude of 4. Alright. Here's where it changes again. So we have 3 times the cosine of 2x. So we are going to graph 3 times the cosine of 2x. Well, what's the amplitude? That's 3, right? That means our range is going to go from -3 to +3. Now look inside the cosine, you have a 2x, which means my period's going to be 2 pi divided by the absolute value of that coefficient of 2. Okay, so 2 pi divided by 2 gives me a period of pi. So in other words, we're actually going to have a period of pi in this case. So let's put pi right here. No, let's not. Let's still do the normal graph. So there's pi. Here's pi over 2. Here, this time would be 3 pi over 4. This would be pi over 4. Alright, now here's negative pi over 4. Negative pi over 2. Negative 3 pi over 4, and then just plain old negative pi here at the far left. So it's important to label points for 2 periods along your x-axis. Now, what is the cosine? If we put in 0, you still get the cosine of 0, which is 1, times that amplitude of 3, you'll be all the way up to 3. Now put in pi over 4. What's 2 pi over 4? Well, that's pi over 2. What is the cosine of pi over 2? That's 0 times 3 is 0. Now put in pi over 2. That would give you the cosine of 2 pi over 2, which is the cosine of pi. That's negative 1 times 3 is going to be negative 3. Now put in 3 pi over 4, that'd be the same as the cosine of 3 pi over 2, which is 0, times 3, which is 0. Now put in pi, that would give you the cosine of 2 pi, which is 1, times 3 is 3. So let's start with the curve that way. Alright, so there's the curve going to the right. Now let's go left. So put in negative pi over 4. That would give you the cosine of negative pi over 2, which is going to be negative 1 times 3 is actually... No, wait a second. The cosine of negative pi over 2 is 0. Excuse me. 0 times 3 is 0. Pardon me. Now put in negative pi over 2, you'll end up getting the cosine of negative pi, which would be negative 1 times 3 is negative 3. Put in negative 3 pi over 4, you get the cosine of negative 3 pi over 2, which is 0 times 3 is 0. Then put in negative pi, you'll get the cosine of negative 2 pi, which is 1 times 3 is 3. Now let's continue drawing the curve this way. So there is the graph of the cosine function with an amplitude of 3 and a period of pi. All right. Got a few more here. So what about y equals 8 times the sine of x? Y equals 8 sine of x. So our amplitude is 8. To find the period, take that coefficient of the x, take 2 pi divided by the coefficient on the x, which is 1. That gives you a period of 2 pi. So otherwise it's pretty normal with the exception of the amplitude. So here's 2 pi. here's pi. Here's 3 pi over 2. Pi over 2. Alright. There's negative pi over 2. Negative pi. Negative 3 pi over 2. And then negative 2 pi. Alright, so let's start at 0. What's the sign of 0? Well, that's just 0 times 8 is, well, 0. So it still starts at 0. But look what happens when we go to pi over 2. What's the sign of pi over 2? That's 1 times 8. That's going to put you all the way up to 8. Now, what's the sign of pi? That's 0 times 8 is 0. What's the sign of 3 pi over 2? That's negative 1 times 8. That'll end up being negative 8. Then what's the sign of 2 pi? That's 0 times 8 is 0. So let's draw this curve. Fat curve, huh? That's a very big vertical stretch. Look at that. And then we got to go to the left still. What's the sign of negative pi over 2? That's negative 1 times 8. That's going to put you down to negative 8. Now, what's the sign of negative pi? That's 0 times 8 is 0. Now, what's the sign of negative 3 pi over 2? That's going to be positive 1 times 8 is 8. And then the sign of negative 2 pi, 0 times 8 is 0. So let's draw this all the way down here. As you see, that is a nice big vertical stretch with an amplitude of 8. That is huge. Shouldn't be too many more. I have 2 more. Now we have half of the sine of pi over 4 times x. So we have half of the sine of pi over 4 times x. Well, your amplitude's that 1/2. So this will be vertically shrunk. Now let's find the period. The coefficient on the x is pi over 4, so this would be 2 pi over 4, which would give you 2 pi over 1 times 4 over pi, which means your period would be 8. So your period is just plain old 8, no pi. So let's put 8 here. Here's going to be 6. Here's going to be 4. There's going to be 2, and then there's 0. 8. I'm off a little bit. Hold on. 8. Here's 6. There's 4. There's 2. There we go. That makes more sense. Alright, now, let's see. There's negative 2. There's negative 4. -6, and -8. So we have 2 full periods still, but this time you don't see any pi's on the axis. You just see regular numbers because your period's 8. Well, let's still put in 0 for the x. Sine of 0 is 0 times the half is still 0. That hasn't changed. Now let's put in 2. If I put in 2 for x, that'd be pi over 4 times 2, which is pi over 2. Sine of pi over 2 is 1 times half is going to be 1/2. That'll put me out here. Now what about 4? If I put in pi over 4 times 4, it gives me the sine of pi, 0 times a half, that's still 0. Now this time I put in 6 for x, that'd be 6 pi over 4, so that'd be the sine of 3 pi over 2, which is -1 times half is -1/2. Then if I put in 8 for x, I'll get the sine of 2 pi, which is 0 times half, which is 0. So as you see, this has definitely vertically shrunk. It's hugging the x-axis more. Now let's go in the negative direction. Put in -2 for x, that'd be the sine of -pi over 2, which is -1 times half, that'd be -1/2. Now let's put in -4 for x, that'd be the sine of -pi, which is 0 times half, still 0. Now put in -6, so the sine of -6 pi over 4 is the same as the sine of -3 pi over 2, which is +1 times half, which is half. Then put in -8, so the sine of -8 pi over 4, the same as the sine of -2 pi is 0 times half is 0. So let's draw this curve going this way. So there is the graph of your sine function with an amplitude of 1/2 and a period of 8. And I got one more and then we are done with this lesson. All right. Y equals 2 times the cosine of 6 pi x. So we have 2 times the cosine of 6 pi x. Well, your amplitude is 2. So that's your amplitude. Now your period's going to be that 2 pi divided by 6 pi, which means your period is 1/3. So you have a period of 1/3. So let's go out here to 1/3. All right, let's see. So that'd have to be 1/6. Now what is halfway between 1/6 and 1/3? There's a reason I'm doing this. So that's going to equal 1/6 plus 2/6 all over 2. I'm just mathematically trying to figure out what's halfway between 1/6 and 1/3. So that's going to be 1/2. Yeah, it'd be 3/6, 1/2 divided by 2. Well, that'd be 1/4. So halfway between 1/6 and 1/3 is actually 1/4. So here's 1/4. All right. And then, of course, halfway between 0 and 1/6 is going to be 1/12. All right, so we got our points plotted in the positive direction. Now just duplicate this in the negative direction. -1/12, -1/6, -1/4, and then -1/3. Alright, we're ready to proceed. We got all our points on the x-axis labeled, so still put in 0. You'll get the cosine of 0, which is 1 times 2 is 2. Now put in 1/12. So 6 pi times 1/12, that would be pi over 2. So what is the cosine of pi over 2? That's 0 times 2 is still 0. Now put in 1/6 for x, so 6 pi over 6 is, well, that just turns into the cosine of pi, which is negative 1 times 2. That would actually give you negative 2. Now put in 1/4, that would turn into 6 pi over 4, which is the cosine of 3 pi over 2. That's 0 times 2 is still 0. Now put in 1/3, 6 pi times 1/3, that would be the same as cosine of 2 pi, which is 1 times 2 is 2. So let's start drawing this curve. And there's your curve for the right side. Now put in negative 1/12. That would give you the sine of the cosine of negative pi over 2, which is 0 times 2 is still 0. Now put in negative 1/6. You would get the cosine of negative pi, which is negative 1 times 2 is negative 2. Put in negative 1/4. That would give you the cosine of negative 3 pi over 2, which is 0 times 2 is still 0. Put in negative 1/3, you get the cosine of negative 2 pi, which is 1 times 2 is 2. Now let's draw this curve going left. And there is your cosine function with amplitude 2, period of 1/3. So that's it for the standard graphs, your basic graphs of sine and cosine with different stretches and shrinks. The next lesson we're actually going to do reflections and transformations of the sine and cosine functions, which will shift things right or left or up or down. So I hope everyone has a great day. Take care.